In this lesson, you will learn about the reasons behind the establishment of ETOPS, which is the acronym for Extended Range Twin-Engine Operational Performance Standards, and the basic rules and conditions which permit twin-engined airliners to operate beyond the ranges based on flight time on one engine, which used to be considered safe for diversion in the event of engine failure. In the early days of post-Second World War airline development, when all airliners were piston-engined, it was considered unsafe for twin-engined aircraft to fly routes that were beyond 60 minutes flying time from a suitable diversion airfield in case of engine failure. As jet-powered airliners were developed and entered service, they proved more reliable than piston aircraft, but were still restricted to a 1-hour diversion by the American FAA, although ICAO regulations allowed for 90 minutes. In the 1970s, as the first twin high-bypass turbofan airliners entered service, it soon became apparent that their extra power and economy enabled them to rival the current three-engined wide-body jets. It was the proven reliability of the engines, though, that led to the establishment of ETOPS. Initially, in 1985, the FAA approved guidelines for the granting of a 120-minute diversion time sufficient for direct transatlantic flight. The first ETOPS rating for the Atlantic was awarded to TWA, initially for a 90-minute diversion time, but which was extended to 120 minutes after operational evaluation. In 1988, the 120-minute ETOPS limit was made extendable to 180 minutes, subject to stringent technical and operational conditions. The ETOPS 180 regulation was first used operationally in 1989 and was also adopted by the Joint Aviation Authority in Europe, the JAA, now EASA, the ICAO and other regulatory bodies. It is based on the premise that there will not be an engine shutdown more than twice in 100,000 engine hours. Statistics have shown that turbines are extremely reliable components, and that the engine ancillaries, such as pumps, control systems, etc., are more likely to fail. For this reason, engines may have duplex systems, which can give them the required reliability rating. Alternatively, aircraft can be fitted with an auxiliary power unit, APU, and a ram air turbine, or RAT, to provide bleed air and electrical and hydraulic power. On the North Atlantic, which is covered by ETOPS 120, some diversion airfields, particularly in Iceland and Greenland, are subject to sudden changes of weather in winter, which render them unusable as diversions. To allow for this, the JAA gave a 15% extension to the 120 minutes, giving 138 minutes diversion time when these airports were closed. Various ETOPS ratings are awarded to both aircraft types and airlines, depending on their capabilities and operation, and subject to approval tests. An operator must have operational certification and type approval before carrying out ETOPS flights, and are also required to carry out reliability programs on equipment. An ETOPS 180 with 15% extension to 207 minutes covers 95% of the Earth's surface. But some areas, such as the Antarctic and some areas of the Southern Oceans, are still excluded from twin-engine operations. There are pressures on authorities in some parts of the world to grant temporary case-by-case extensions to 240 minutes diversion time. But 4 hours on one engine is a long time, and the establishing of adequate reliability would require a substantial amount of statistical proof.